up to this point, we've been looking at linear functions. So today we're going to look at linear and nonlinear functions and being able to determine which is linear and which would be a nonlinear. Your essential question, how can we model relationships between quantities? Make sure in your notes that you are writing these I can statements. So by the end of this lesson, you should be able to say I can recognize when an equation is a linear function. I can generate functions that are not linear and explain why they're not linear. Okay, so let's talk about the difference between linear and nonlinear functions. And we've gone over linear, but just as a recap, linear functions, they have a constant rate of change. They have that constant slope all the way down through the set of ordered pairs. And when you graph that function, it will create a straight line. Okay, so which is why they call it a linear function. A nonlinear function is not going to have a constant rate of change. So as you look at your change in y over your change in x, it's not going to be consistent all the way down that table or in the graph. And when you graph it, you're not going to get a straight line. So those points will not create a straight line when you put it on the coordinate plane. Okay, so already in the examples, we're going to start off by determining whether the function is linear or nonlinear. And we're going to look at this function right here. So sometimes they can give you a function in an equation. They can give it to you in a graph. They can give it to you in a table, or they can give it to you as a set of ordered pairs that you could either graph or put in a table. In this particular example, they've given us our 4 ordered pairs in a table already. So find the constant rate of change. Or you can graph these ordered pairs. You can graph them, see if they make a straight line. If they don't fall on the same straight line, if you can't take a ruler and connect every single one of these 4 ordered pairs in one swoop, it's not going to be a linear function. In this particular example, I'm going to show you and recap on how to find the rate of change. We're going to look at how the change is either going to be consistent or not consistent. So remember, the rate of change is the change in y. So in this case, we're going up 1 over the change in x. And in this situation, we're going up 2. So right now, we have a rate of change of 1/2. We want to see 1/2 all the way through that table of values. If not, it's going to be nonlinear. In the next one, it's going up 2. And for the x's, it's going up 2. This will simplify to 1. So right off the bat, we had a rate of change of 1/2. Then it went up to a rate of change of 1. That's not a constant rate of change. We can do it again. In this case, we've got a change in y of 3 and a change in x of 2. That gives us 1.5. So our rate of change is different each time. So it looks like it's increasing as our ordered pairs are going down in the table. This is an example where it does not have a constant rate of change. So this is a linear function. If we were to graph these 4 ordered pairs, they wouldn't fall on the same line. So you can look at it both ways. All right, another example. Again, determine whether this particular function is linear or nonlinear. So here's an example where you're given just a set of ordered pairs. You can work this one of 2 ways. You can put them in a table, and look at their rate of change, see if it's constant, or you can graph it. You can graph these 4 ordered pairs on a coordinate plane and see if they make a straight line. Both of those methods will give you the answer you're looking for. Again, let's look at the rate of change here. Looks like the y is going up 2 when the x is going up 1. So that's 2 over 1. Y's are going up 2. X's are going up 1. So far it's constant. Again, y's are going up 2. X's are going up 1. So if you notice, constant rate of change. That rate of change, or the slope, is 2. Since that is a constant rate of change, this will be linear. We can plot these 4 ordered pairs on a graph, and we will get a straight line. So in this situation, we would put a linear function. Okay. Make sure you're getting all of these examples in your notes as we go along, so that when we get into class, you can have those examples to go off of, as well as the others we'll do together. So, yep, here's an example of a linear function, constant rate of change. Let's look at one more example. This is an example where you are going to be looking at an equation that represents a function. And we are looking to see if this equation represents a function that is linear or nonlinear. My suggestion for this one is to make a table of values. We don't have any ordered pairs, so we kind of need to make our own. So a table of values, remember you've got your x, your outcome will be your y, your rule is what y is equal to, which in this case is x squared plus 2. Pick values for x, keep them small, plug them in to get your y's. So I'm going to get this started, and then I want you to finish this after the video's over, and then when we look at our notes and we talk about this in class, we're going to come back to this as a class. So make sure that you finish this table after I show you how to get it started. So we've got a -1 as our first value for x. Now remember, that's x squared. So we're going to be squaring -1. -1 squared is 1. 1 plus 2 is a 3. So that's going to be one ordered pair that we're going to graph. After we get the other 3, you'll have 4 ordered pairs. Graph that function and see if it gets a straight line. If you do not get a straight line, then this is going to be nonlinear. But you need to get your 4 sets of ordered pairs in order to do that. So after this video, I want you to finish this off. When we go over this in class, I'm going to look and see if you have this done, and we are then going to take it from there and look at the graphs.